Stencil components are rendered using JSX, a popular decorative template syntax. If you ever use React, chances are you've used JSX before. Stencil embraces the fact that rendering logic is inherently coupled with other UI logic, such as how events are handled, how state changes over time, and how the data is prepared for display. Each stencil component has a render function that returns a tree of components that are rendered to the DOM at runtime. Let's say it how it is. JSX is just XML. More specifically, JSX is a preprocessor step that adds XML syntax to your JavaScript. Just like XML, JSX tags have a tag name, attributes, and children. If an attribute value is enclosed in quotes, the value is processed as a string. If we wrap the value in curly braces, it's processed as a JavaScript expression. This allows us to render dynamic data. You'd be excused for thinking JSX is just HTML, but that's not quite the case. If you're familiar with ES6 template variables, JSX variables are very similar, just without the dollar symbol. You may notice something different about some of these attribute names. More specifically, class name in place of class and HTML4 in place of 4. Because JSX processes down to HTML, identifiers such as class and 4 are already reserved and therefore discouraged as attribute names. Sometimes we need to add conditional logic where the result of the expression renders different content. In these cases, we're able to use normal if-else statements. In the example shown, if the variable's name is not defined, we just render a different component. We can also write inline conditionals using JavaScript's ternary operator. A cool thing to note is that Stencil tries to optimize and reuse DOM elements whenever possible to improve performance. This means the two examples shown are equivalent. There is one trade-off here. If the value of some condition changes, the internal state of our component won't change and lifecycle methods like component will load aren't fired. Instead, the conditional triggers an update to the same component. Later on in the series, we'll look more in depth at lifecycle hooks and how we can use them to manipulate and react to component changes. If we want to destroy and recreate a component instead, we just need to add a key attribute. This tells the Stencil compiler that the components are actually different. JSX provides us with a robust toolbelt for rendering our components. We can spend a long time going through slots, loops, handling user input, etc. As developers, the best way to learn is by practicing. I strongly suggest looking through the excellent information available online and practice, practice, practice. Let's have a look at some of the core logic that makes up a Stencil component. Stencil's API can pretty much be condensed into a set of decorators, lifecycle hooks, and rendering methods. If you're new to TypeScript, some of these concepts may be new to you. Let's start with decorators. Decorators are a construct used by Stencil to collect metadata about a component, its properties, attributes, exposed methods, events, and associated style sheets. During compilation, Stencil gathers all this metadata and removes the decorator from the final output. Stencil uses 8 decorators, most of which are situational based on what we need our component to do. In this video, we'll look at a few of the most used decorators: component, props, and element. In future videos, we'll look at how to utilize internal state and reactive data with the state and watch decorators, how to expose public methods with the method decorator, and how to emit and listen for events using the event and listen decorators. Every Stencil component must include a component decorator, which is imported from Stencil's core package. Information such as the tag and external styles can be set here. Let's take a look at the possible options we can pass at a component decorator. The only required property is the tag name, but there's plenty of others. The tag property defines the name of the web component. The tag name must be globally unique to avoid conflicts. A good convention is to use a unique prefix for all your components within the same collection. To conform to the web component spec, every tag name must include a dash. When the scope property is true, the component will use scoped style sheets. We'll look at this in more detail in an upcoming video. When the shadow property is true, the component will use native shadow DOM encapsulation. If the browser doesn't support shadow DOM, the component falls back to scoped encapsulation. We'll look at this in more detail in an upcoming video. The style URL property allows us to specify a relative URL to an external stylesheet file. Usually this is a CSS file, but in a later video we're going to look at how to use Sass and less files instead. This property is similar to the style URL property, but allows us to specify multiple style sheets. Instead of using external style sheets, the styles property allows us to add inline CSS as a string. One limitation here is that only CSS can be used. Sorry to all the Sass and less users. Sometimes we want to include assets in our component. This property allows us to specify relative links to asset folders. Props are custom attributes that are exposed publicly on a component that a developer can provide values to. They're used to define properties and pass data down from parent to child components. Components need to explicitly declare the properties they expect to receive using the prop decorator. Depending on how we define a component, we can set the properties as attributes in different ways. In HTML, we set attributes using dash case. In JSX, we set attributes in camel case. And when creating a web component using JavaScript, we can access the properties directly. Just as with the component decorator, the prop decorator allows us to set some properties to change its default behavior. By default, a prop is immutable from inside the component. This means that once a value is set by a user, the component can't internally update it. This is to help us avoid creating bugs by accidentally overwriting the user value. However, by setting the mutable property to true, we're able to allow these mutations. Usually an attribute key is the same as the property's name. Although these two are strongly connected, they're not necessarily the same thing. Consider the following example. The component has 3 properties, but the compiler will only create 2 attributes as controller is not a primitive value and DOM attributes can only be strings. By explicitly specifying the attribute name, we can change this default behavior. In certain cases, it's useful to keep a prop in sync with an attribute. We can achieve this by setting the reflect property. By doing this, values set within a component will be rendered in the DOM as an HTML attribute. The final decorator we'll be looking at is element. The element decorator allows us to access the host element within the instance class. This returns an instance of an HTML element so that we can call native DOM methods and events. In the next video, we're going to learn about a Stencil Components' internal state and how to utilize reactive data. We're also going to apply all the concepts we've learned so far by creating our first awesome component. I'm definitely looking forward to that. Make sure to hit like and subscribe so you don't miss the next video. See you in the next one.